Good afternoon everyone. Today we have such an amplifier in repair. It is Kicx RTS 4100. That is 4 channels of 100 watts each, and at the same time it is as big as 4 of my hands. Here are the specs. 100 watts per channel at 4 ohms or 190 watts bridged. It can also be switched on at 2 ohms and it will give 200 watts. 4 channels of 200 watts into 2 ohms. That's already interesting. Not only its size is unusual, but also the location of the controls. Usually they are located at the ends, but not in this case. From left to right, the power terminal. 3 30 amp fuses, power protect indicator. Next, speaker output, filter block, remote regulator connection, RCA inputs, and high-level input. Inside is a nightmare of modern marketers, because I haven't seen so much free space on the board for a long time. You can put a couple of transformers and a dozen capacitors here. But we have a clearly separated part of the inverter, a clearly separated part of the filters, and the power amplifier unit itself. Everything is very nice and clear. This amplifier is sitting in defense, and it looks like I've already found the cause. It feels like these 2 resistors have a bit of a charred look to them, and they're used to power part of the filters. When power is applied, we see that the unit is current limited. The amplifier starts, then the limitation is triggered, which indicates that part of the converter is probably okay, but some pair of output transistors is broken. Let's run some preliminary diagnostics. And let's compare the resistance in each of the 4 channels. 2 mega ohms. This one's only 20 kilo ohms. There's also 2 mega ohms on the bottom. Stop! And here I didn't pay attention to the increased resistance of 2.5 mega ohms. I should have. It turns out that the problem is in channel number 1. Check the transistors in this channel. Base collector breakdown. Base emitter breakdown. The neighboring pair seems to be okay. Let's see what transistors are installed here. A common pair is B817 to D1047. I've got one of these. I take the board out, swap them, and look at the result. I've soldered this pair of transistors. The power supply has a current of 750 milliamps. And strangely enough, the resistors, though burnt out, still do their job. Only with a skew of a couple of volts. I guess their resistance has changed after all. I'll have to replace them with more powerful ones. I checked the parts in the faulty channel. Everything's fine. You can put in bigger transistors. Started checking the sound. In the first channel it appeared, but here the following special effect occurs. You can clearly hear that there is a constant voltage at the output. Quite a lot of it. 33 volts, and we've got it right here on the very first pair. The amplifier's been repaired before. And it's like the 2 leads of this transistor have been soldered together. I'm going to remove this knot now and see if it helps. We're looking at the screen. And everything's fine. The goat's gone. And even the transistor is good. What immediately caught my eye is that the current on the power supply has dropped to 650 milliamps. And there is no constant voltage. Faced with another problem. One rear channel does not work. The sound is very quiet. It's caused by this switch here. Spray some contact cleaner on it, switch it around, and it should work. I had to change another pair of output transistors. I noticed that from time to time at low volume the sound in one channel starts to wheeze. And if you take a transistor tester, it tells us that it is not a transistor but a capacitor, and the second one is tested as 2 diodes. At the same time, the multimeter sees no abnormalities, transitions like a good one. It's time for the measurements. The application is 200 watts at 2 ohms. Therefore, two 4 ohm resistors in parallel. All eyes on the bottom right corner. 18 volts, no distortion. Do the math, and that's 160 watts. That's a little short of 200. Now 4 ohms. Disconnecting one resistor. 24 volts. And that's 120 watts instead of 100. So 4 ohms is a quarter more than the application, and 2 ohms is a quarter less. Such a repair, such an amplifier. Goodbye, everybody.